So we've been introduced to the auto-wired annotation, and we've seen that how it is actually capable of annotating some injection point and specifying the injection point and telling the Spring IOC container to inject the dependencies. So actually there are a bunch of other ways to address the bean definition. So when we specify the injection point, we tell the Spring to find a bean definition that could satisfy that injection point. So so far we've used actually the addressing the bean definition by their types. So by using the auto-wired, we are using by type, actually identifying by type. Now there are a bunch of other ways to identify the bean definitions and resolve them. And there are actually three ways. The first way that we've been introduced is identifying by a type. The second way is identifying by their ID or key or bean name, which the bean names are, as you know, are unique inside the IOC container. And the third one is actually, they call it combinatorial key or combinatorial ID, which uses actually both of them, which has a part of actually specifying the type and another part which is the ID or key or bean definition name. So let's just first start with the auto-wired that we've been seeing already. So with using actually auto-wired, let's actually create the class. I'm just going to use the field actual field injection point just for the simplicity here. But as you know, using the field as an injection point is not a good idea and it's not recommended. So let's say that we have this engine, for example, engine class, which is a component itself, and we want to inject it actually here, engine, and annotate this class with auto-wired. So by annotating this with auto-wired, we are telling to go and find a bean definition appropriate for this injection point and satisfy here with that. So actually this is like identifying the bean definitions by type. So if I run application, you'll see that we have a bunch of bean definitions here. One of them is car with the type of car. The second one is with the type of engine, and the third one is truck. And so as you can see here at this injection point, it is seeking and searching for the bean definition that their types could satisfy this point. And we've talked about this a lot. So this is like identifying the bean definition by type. And actually there are a lot of benefits with this methodology. The first one is that identifying by type is they say it is type safe, because the compiler helps and checks for the types here. The other one is that there is no misspelling. You will see that with identifying with keys, there might be some misspelling and typos. But here, because it is types in classes and the compiler checks them, there is actually no way of seeing misspelling or something like that. But there are a bunch of disadvantages to this method of injection and injecting, which is identifying the bean definitions by type. The first one is that the key that we are using. So now here we are using this type as the key. We could say that this engine class is the key here. And when it tries to seek and explore these bean definition, it just looks for their type, and uses this engine as the key. And when it finds one bean definition, it creates an instance, asks an instance off of it and injects here. So this class type is used as a key here, as an ID here, to go and find the bean definition and resolve one. But as you know, this key is not unique, and because we could have a bunch of other engines that are extending this class, engine class, and let me just real quick show it to you. For example, we could have a super engine, let's say. I don't know, something like that, which extends the engine, and which is a component here. And you'll see that it didn't fail because here, let me just change the name. Yeah, you'll see that it is failing, and it's saying that it is finding two matches. One is engine and the other one is super engine. And the reason is that here for this injection point, the engine is the key, and it searches all the bean definitions by this key, because there are two bean definitions that their types could satisfy this, you know, and because of that, we could say that it is not unique. You know, this key is not unique. We could not use this as a unique key. That is one disadvantage to identifying by type. The other disadvantage is that taking this type as the key is not arbitrary. You know, we could not have arbitrary names here as the type name. For example, let's say that we want to structure them with dots. You know, we could not have arbitrary naming policy here, and we are limited and restricted to how the Java forces us to name our classes, and that is another disadvantage. And the other disadvantage is that it is not explicit, actually, meaning that it doesn't point to a single and one and only bean definition. And by other ways that we will be introduced in this episode, you'll see that how these problems actually go away, but they have other problems of themselves, actually. So this was using the types as keys for identifying bean definitions. I'm just going to show you something else here, that there are a bunch of annotations outside the Spring, with, for example, like annotations inside the JSR 330 and annotations inside JSR 305, 305, that the Spring recognizes them and allows you to use them, as well, like its own annotations. So there is this annotation at inject. I think it is inside the JSR 330, and that is exactly like the auto-wired. Its capabilities exactly like auto-wired. So if you want to use this add inject annotation inside the JSR 330, you have to search for Maven Central javax.inject, and inside the Maven Central, you could find this artifact with the version 1. It is for 2009 actually, and you could copy this line and bring it inside the build Gradle and paste it here. And after refreshing the project, you will be accessing the custom annotations inside the javax inject, which is from inside the JSR 330. And one of those annotations is this add inject annotation. Let me show you. Add inject. And this add inject is from the javax.inject package. So we could use this annotation instead of the auto-wired, and it will perform exactly the same as the auto-wired. So saying that, it means that it performs by identifying actually by type. It seeks for types, inside among the bean definitions. But there is a slight difference here with the auto-wired, and that is this inject is always required. Actually, there is no required attribute inside it. And with auto-wired, we have this required attribute that we could set true or false. But here with inject, we have to use nullable or optional to actually overcome the issue of not being able to satisfy this injection point. So we actually see how to use auto-wired and add inject annotations to identify the bean definitions by types. Now, and we see that actually by using this pattern, we are actually safe and the compiler helps us because the types are safe, but the keys, which are the types here, are not flexible and are not unique. So the second one, the second thing that, the second way, let's put it that, the second way that we are going to learn to how to help the string to identify the beans actually, is identifying them by their key or by their ID or by their name. So as you know, this name here, which is the bean definition name, and let me just delete this one real quick and run it again. So as you can see, there is this name for each bean definition. One here, one here. The name here is the car that we have overridden, but the others are their default names. These names are the bean definition names, and they must be unique. So if I want to change this, let's say to the car and run it, you'll see that it fails, and it says that we have conflicting bean names with the name of the car. So as you can see, the name of the bean definitions should be unique, and we've not seen the @bean annotation for defining bean definitions inside the Java configuration. So when we see the @bean annotations, you'll see that there as well, you have to specify unique names for the bean definitions. But okay, so we saw that these bean definitions should be unique, and we could take them as the key or the ID for resolving and finding a specific bean definition. But as we said before, this inject and out-of-wire, the way that they perform and work is that they identify by type. But what if we want to identify by name? So there is this annotation named @resource, again another annotation outside of the Spain, which is from JSR 305, and we could add it to our project by, I think, Java x.annotation API or something like that. Let me see if I'm right. Yeah, that is the one. So the version actually doesn't matter here. Let me just grab this one and copy it here. And let's sync the project. And yep. Okay. Now we could use this @resource annotation from inside the javax.annotation package that we recently just added to the project. So what it does is that it actually tries to resolve the bean definition by its name or by its ID or key. And because the bean definition name is unique, we could use it as an ID or key here. So if we actually change this value here, this type, sorry, to object, and I'll explain it why. So I'm changing it to object, and I'm saying that I want you to go and find a bean definition by name, by its name, that has this name of, let's say, let me get rid of this, the car, has the name of truck. Okay, and I think it is name or something like it. Yeah, the attribute is a name here. So if I run it, you'll see that it works. And let me add the toString here for the car to show that what just happened. So inside the car instance, the engine instance is an instance of the truck class, because actually we ignored the type and we just tried to find it by the name, by the bean definition name, identified by the bean definition name. So let me just define a super engine here, because adding the truck as engine is ridiculous. So let's make it a component here. And also we have an engine as the component. And inside the car, let's say that we could tell it to inject with the engine or the super engine. So these values that I'm using here is the name of these bean definitions. And if we override them, we have to use the overridden version. So again, you can see that the super engine instance is injected here. So here we are actually using this name as the key. So we are here identifying the bean definitions and resolving them by only their names. We are not using the type here. And I've just changed the type to object. So what are the advantages and what are the disadvantages here? The advantages is that this name is arbitrary. We could use any naming here. We could say, for example, A.B. My engine, for example. I don't know, for whatever reason. So I'm just structuring the name of the bean definitions. And if I run it, you'll see that it will fail, and it will say that there is no bean named with this name available. So it is looking for only the name here, not the type. And if we change the name, override the name of one of them, it will just work actually. You'll see that it is working. So one advantage here is that it is arbitrary. We could have any naming convention here. We are not restricted to the name of the type like we were with at auto wired and inject. But at resource, we could have any naming. The other advantage is that it is explicit. By explicit, we mean that we are identifying a one and only one, a single specific bean definition, specific one. So it is explicit, and it is unique because the name of the bean definitions are unique, and we are pointing to one and only one bean definition. And if we don't have any bean definition with that bean name, it will just fail. So that is another advantage. But the disadvantages here is that because we are using string literals, we could have typos or misspelling when the number of the components actually grow in our project. That is one problem here. And the errors could only be notified just only in runtime actually, when the application is running. So and the compiler cannot help us with the type. Another thing that I want to mention about the @resource annotation is that it has some restrictions and limits compared to the @auto wired and an inject annotation. And that is, the resource annotation could only be used on top of the fields and on top of the setter methods with only a single parameter. So despite resource annotation, as you know, the @auto wired annotation could be used on top of the constructors as well, and also on top of the methods with more than one parameter. But that is one limitation of the resource annotation. The other limit of the @resource annotation, it only supports the optional interface, and it doesn't work with @nullable annotation. And another thing that I wanted to mention here with @resource is that if you don't specify the name here, if you don't specify the name, it will first take this name, the name of the field or the name of the parameter with the setter methods. It will take that name and will try to find a bean definition that has the same name as this name, because you've not given the name. And if it finds one, let's say that it is, let me see, the super engine or the engine. Let's change the name to engine here. Or we could change it, for example, to truck to prove that it is taking this name, the name of the field, as the name. Truck. Okay, as you can see inside the car, it has injected an instance of the truck here because it looks by the name, you know, by the name of the annotation. And because we've not given any name to it, it will take the name of the field here. So the other thing that I want to mention is that when we don't provide any name and it looks by the name of the field or the name of the parameter, if it doesn't find any, then it will fall back to identifying and resolving by type. So let's, for example, change this name to, for example, engine. And let's name it E. Okay, we changed the field name to E, and now it will try to find for the bean definitions with the name of E. And because it won't be able to find any, because there's none, it will fall back to resolve this injection point by its type. So now we've got one here, which is the engine, and the other one is a super engine that should extend the engine. So now because we've got two candidates here that could be injected, you will see that it will fail. It will fail because it is finding two matches, you know, the engine and the super engine. So as you can see, the resource is capable of identifying the bean definitions by their names or by their IDs or keys, you know, because they are unique. And when we don't explicitly give any name, it will first try to resolve it by the name of the parameter or the field. And if it fails, it won't throw exception. This time it will try to resolve by the type. And now we are introduced to this way of actually identifying by the name of the bean definitions. And you can see that it is unique, explicit, it is arbitrary, but it has the problems and disadvantages of being actually we might misspell or have typos, or we might get to the errors at the runtime. And those are the problems with the at resource and identifying only by ID or key or bean definition name. The third way of identifying the bean definitions is actually the combinatorial keys or IDs. You know, with this third version, we are combining the two aspects of the other two ways. You know, we are having both a type and also a string key as a compound key. So they call it combinatorial key to help the Spring to resolve the bean definitions better. So again, by using the at resource, if instead of object, if we specify a specific type like engine, and also if we explicitly specify the name of the bean definition that we expected to resolve, like a dot b dot. Let's see, the name was, the name is super engine. Super engine. Okay. Now if I run, you'll see that we were expecting an engine, and also we were expecting an engine that had exactly the name of this super engine bean definition. So you might argue that nothing changed here, you know, but by specifying a type and an explicit name here, so with two of them, we have a combinatorial key. So now we have all the advantages of the first type, which was identifying by key. So the keys were arbitrary, were explicit, and were unique. Now we have that part here. We could specify the name and ID or whatever. And also we have the benefits of the second way of identifying the bean definitions, which were identifying by their types. So now we are here also giving this hint about the type. We are saying that the type should be should satisfy the engine. So we have all the benefits combined together, but we have that disadvantage of using the keys here again, because we could misspell or have typos. And we could exactly get rid of this as well with the Java configuration. When we will be introduced to the Java configuration with the @bean annotation in this episode, in the future episode, you will see that there we could have the name of the methods as the name as the unique name of the bean definitions. And because we are using the method names, then there is no way to have typos and misspelling. So if I want to wrap it up, we are introduced to 3 ways of identifying the bean definitions. The first was identifying by type, which we use the @autowired and @inject. And with using them, what Spring does is first tries to identify and filter all the bean definitions that has the same type or the descendant or child of that class, and then among them selects one of them. The second way was identifying bean definitions by their IDs, keys, or names, which were unique, and it had a bunch of advantages and disadvantages. And we've used @resource annotation and also with the type of object, because we are ignoring the type and we are only asking for the instance by its ID, only by ID. The third way was the combinatorial key, which we use the @resource annotation again, but this time we had to explicitly specify the name of the bean definition and also explicitly specify the type of the injection point. So having these two, we help the Spring to identify the bean definition, exactly, and also help us with the type, resolving the type at the compile time. And those were the 3 ways of identifying the bean definitions. Now, I just want to real quick here mention the first way that we mentioned, identifying by type. So by identifying by type, as you remember, the keys were the types. And as you saw, we could have, for example, engine and super engine, 2 candidates for the injection point. And in that point, the Spring actually would only fail. You will see in the Java configuration type that we could have multiple bean definitions with this single type, actually, by not just extending, for example, the engine class to super engine. We could have 10 bean definitions with the type of engine. So what happens when we have multiple bean definitions, not only one, multiple, more than one, that could satisfy a single injection point, and that injection point just tries to identify by type? What happens is that there is a situation of ambiguity. So we have an ambiguous situation there that the Spring should be actually able to resolve that situation, And the next session, we will talk about the ways about helping the Spring to resolve the ambiguous situation. Because as you know, inside the Spring, we mostly use the @autowired. We are mostly working with identifying by type. You see this @resource and @inject annotation rarely, maybe inside legacy projects. So because we are using identifying by type and we are using @autowired annotation, so we must be able, to teach the IOC container to resolve the ambiguous situation. And we will be introduced to qualifier and primary annotations for that.